Picture a spider dropping from the ceiling onto your arm. Your whole body reacts before your brain even finishes processing what it's looking at. Heart rate spikes, muscles tense. You're already moving before you've consciously decided to. Now picture a crab sitting on a beach towel a foot away from your hand. Same number of legs, roughly the same size, and yet almost nobody flinches. Why does one of these trigger a primal alarm and the other barely registers? Scientists have a name for the leading theory: preparedness theory. The idea is that evolution didn't leave fear entirely up to individual experience. For threats that killed our ancestors again and again over millions of years, our brains may have been pre-wired to learn fear of them almost instantly and to hold on to that fear stubbornly, far more than we do for genuinely modern dangers like electrical outlets or speeding cars, things that are statistically far more likely to kill you today. Your amygdala, the brain's threat detection center, appears able to flag certain shapes as dangerous before the rest of your brain has even finished consciously identifying what it's looking at, which is why the reaction to a spider often feels like it happens before you've actually thought anything at all. Snakes are the clearest example. Researchers have found that snakes have been a recurring threat throughout tens of millions of years of mammalian evolution, and that people with snake phobias identify a snake hidden among other images significantly faster than they identify a flower or a mushroom. Even today, snake bites are estimated to cause between 81,000 and 138,000 deaths worldwide every year. The threat isn't ancient history, it's ongoing. Spiders looked at first like an equally clean case. In 2015, a study out of Columbia University asked 252 people to spot specific images hidden among cluttered, distracting visuals on a screen. Spiders were detected faster and more reliably than other fear or disgust-inducing images, including flies and hypodermic needles. The researchers pointed to something specific. Venomous spiders with vertebrate-targeting toxins existed across Africa for tens of millions of years before our own species evolved, coexisting with our ancestors the entire time. A bite might not have killed you outright, but it could leave you incapacitated for days in an environment where being unable to move was often a death sentence on its own. Then came proof this wasn't learned behavior. Researchers at the Max Planck Institute in Germany tested 6-month-old babies, too young to have learned anything about spiders from culture or cartoons. When shown images of spiders and snakes, the infant's pupils measurably dilated, a physical stress response, compared to when they were shown flowers or fish. Whatever this fear is, it appears to already be sitting there before a child has ever been taught to be afraid of anything. Case closed, then. Except for one stubborn detail that doesn't fit. Unlike snakes, the vast majority of spiders were never actually dangerous to humans. Only a tiny fraction of the 35,000 known species carry venom that threatens people. If ancient, lethal danger were the whole explanation, the math doesn't quite hold up the way it does for snakes. That gap has pushed some researchers toward a completely different kind of explanation, one that has nothing to do with predators at all. It's called the disease avoidance theory, and it argues that spider fear isn't really about danger, it's about disgust. The reasoning goes like this: spiders move erratically, unpredictably, and often appear in dirty, cluttered, or decaying environments, corners, basements, drains, the kinds of places historically associated with contamination and disease. Some researchers even trace this back further to the medieval plague era, when the true cause of the disease was unknown, and spiders, closely associated with the same dark, unsanitary conditions that spread illness, may have become an unconscious symbolic target for a broader fear of contagion, a fear that then got passed down and reinforced across generations, culturally rather than genetically. It's a real competing theory, and it would explain something the venom theory struggles with: why the emotional reaction to a spider often feels less like fear of an attack and more like revulsion at contact. So researchers went looking for a way to test which explanation actually holds up, and this is where crabs finally enter the story in a way you probably wouldn't expect. A series of eye-tracking studies tested how people react to images of spiders, scorpions, snakes, and crabs flashed as background distractions during an unrelated task. People with a fear of spiders got measurably distracted not only by spider images, but by crab images too. That result points to something more interesting than spiders are dangerous, crabs aren't. It suggests your brain may not be running a search for spider specifically at all. It may be running a search for a shape: rapid, asymmetric, many-legged movement, splayed at odd angles. Spiders match that pattern constantly, in dark corners, dropping unexpectedly, moving fast and erratically. Crabs share the same basic silhouette, and sure enough, they can trigger some of that same alarm. arm, just less often, because crabs move differently, low and sideways, and most people only ever encounter one in a controlled setting, like a beach or a seafood restaurant, not scuttling across a bedroom wall at midnight. That's the closest thing science has to a real answer. Your fear probably isn't calibrated to the species, it's calibrated to the shape and the movement, a pattern recognition system built for a much older world that fires just as easily on anything that matches the pattern closely enough: spider, scorpion, or occasionally crab. There's actually a useful practical thread hiding inside all of this. If the fear really is about pattern recognition rather than a fixed, hardwired target, that also explains why exposure therapy, the standard clinical treatment for phobias, works as well as it does. Repeated controlled exposure to spiders gradually retrains that same pattern recognition system to stop flagging the shape as an emergency. It's not erasing an ancient instinct. It's teaching an old alarm system a new, calmer response to a pattern it's been misreading as a threat. What's still genuinely debated is the fine print underneath the main answer: whether this pattern detection system evolved because of spiders directly, because of a broader ancestral threat like scorpions that spiders simply resemble closely enough, or because of disgust and disease avoidance layered on culturally over generations. Scientists are still working that part out, but the bigger picture is settled. Somewhere in your nervous system, a fast, many-legged shape still sets off an alarm built for a world you've never actually lived in, and once you know that, it's hard to unsee it the next time something skitters across the floor.